Okay. Mm, Okay, good morning, everyone. Today, my group is going to present about and explain the meaning of addition through concrete manipulatives and activities. Next. Okay, when we talk about addition, we can ask few questions. For example, how else can we say add? We can also say add as join, plus, sum, and so on. Or we can also ask, do numbers get bigger or smaller? Or when might you use addition, or can we add more than one number together? These are the few questions we can ask to deepen our understanding about addition. Next. Meaning of addition. Addition is the process of putting two or more things together and counting the total to get the sum. It is a primary arithmetic operation as we use addition more often in real life while we work with money or calculating our bills. Addition is represented by the symbol add, and the symbol is also known as the addition sign or plus sign. There are four types of method to solve addition. First is adding addition sentence, or it is what we commonly say as an equation. Second, addition without regrouping is the addition involves uh, the sum of digits less than or equals to 9 at each place value. While the addition with regrouping is a sum of digits more than 9. It is involve the process of carry forward. The last one is addition using number line. Next, the addition and algorithm. Addition standard in addition standards, we have adders, sum, and symbols. And adders are the numbers on which addition operation is to be performed. Sum is the final answer of the addition. And the symbols using are plus sign and equal sign. A standard algorithm is a step-by-step way to solve a problem. In HO strategies involve rote memorization of ancient algorithms. Rote memorization is the memorization of information based on repetition. Like when we go to exam, we prepare, study, then exam. After that, will forget it. Next time we exam, we will repeat the same process, which is prepare, study, exam, and then forget again. Then the ancient algorithms is like Babylonian algorithms, like what we learned before. But modern teachers have also begun to develop curriculum over the years to effectively teach the idea of algorithms. Multiple ways of resolving complex issues by breaking them into a set of procedural steps. Okay, next.
Okay, so now I will introduce a method that can teach addition, that is, teaching addition with regrouping using manipulatives. The materials that are essential are place value maths and Unified cubes, as shown as in the diagram below, and we can see that the place value maths we separate into two parts. One is tens and another one is ones, and for ones we will prepare each 10 frame. Okay, so Unified cubes is a good manipulative when it comes to teaching addition through regrouping, because we can stick them together and regroup it into 10. Now we can look at the example. What is the sum? What is the sum 17 plus 5? Okay, first using Unified cubes to 17. We stick them together and make it 10, place 10 on tens, and place 5 Unified cubes on ones. Next, add 5 more ones with these colors, and always make sure that we fill the first 10 frame of the top one first before moving to another frame. Okay, so now we can regroup those 10 ones were to make one 10. Now 2 tens and 2 ones. The answer is 22. Next.
Okay, next. The other activities that can be carried out to teach the meaning of addition is by using popsicle sticks. The concept for this activity is grouping or putting things together to get the final answer. So to create this activity, first we need to have this kind of board, just like in the first picture, and of course popsicle sticks. Okay, how this activity works? Okay, first, of course, the teacher will give the question for the student. Okay, like look at the first picture. Uh, given in the first cup is number 3, so the student need to count 3 popsicle sticks and put it in the first cup. Next, move to the second cup. Given number 5, so student need to count 5 popsicle sticks and put it in the second cup. Okay, then to get the answer, student need to collect and count all the popsicle stick in both cups and put it in the last cup. So the student will be able to get the final answer between the sum of 3 and 5. Then the answer will be 8. So in the third picture, the result we will get after student complete all the question. Okay, next.
Okay, then I will go with counting on finger. Counting on finger also a concrete material. Firstly, student will be given this material with question as in the picture given, which is 3 plus 1. Then the student has to drop a finger to calculate the answer, which is 3 plus 1 equal to 4. The number on the first paper will be used first hand, while the number on the second paper will use the second hand. The student, to get the answer, student will add the top finger to get the answer. This method is suitable for just one student or as a recovery activity. Also, this material can be used multiple times because the question can be replaced by another question, and the finger that has been stick can be removed again because the teacher only use sellotape to stick them. This is the concrete manipulative that I create. This is all. Thank you.
Okay, for the last one, this method I think is more to focus on concept of addition. Okay, first step is prepare the item as shown in the picture. So basically, we can choose the item like in the picture, or just do it our own, like do it like a dot on the paper and cut it and separate it with two different colors. And the second step is give it the example how to use them, which mean if you can see, first they need to fill the the square one punya the square one, which mean one white and 5 black. So for example, one white and 5 black equal to 6. So in this case, student needs to fill the block with the white and black item and to make sure they get 6 answer. So next step 3, rewrite it in number sentence, which means 1 plus 5 equal to 6. And then step 4 is student can do whatever that they can to perform the answer 6, like 2 plus 4 or 3 plus 3, like that. That's all from me. Thank you.
Okay, can we see the PowerPoint again? Starting from the last one. Mazreen, is it the last presentation?
Yes.
So Mazreen, show your PowerPoint first. Okay, what concept of addition is being shown here?
I think grouping.
Grouping, yeah? Addition as grouping, is it?
Yes.
Okay, so actually we can say addition as grouping, or we can say this is the set model, okay? Set model or altogether model. So what she has shown here is altogether model. So 1 and 5 altogether becomes 6, okay? So this one, she has explained the altogether model and together with an activity, okay? So this one is good, okay? So this one is okay, Mazreen. The earlier
Thank you,
one was
madam.
the fingers, okay, good. The earlier one was the fingers by Fatin. Fatin showed us how to do this counting on. Actually, it's not counting; it's addition. Addition using finger method. Okay, this is also based on the set or altogether model. So we have two models. One is the set model and one is the measurement model. Also based on the altogether method, but this is using fingers. Okay, showing two sets of numbers, 3 and 1. So 3 and 1 altogether becomes 4. Okay, so this is also okay. Only thing, this one you can only use for limited numbers, below 10, because there's only 10 fingers. Okay, okay. Earlier than this is the popsicle sticks. Okay, this one also altogether model. Okay, 3 and 5 altogether becomes 8. So this is an activity for the altogether model. Okay, before this was the models, the concrete models using the, yes, this one. Okay, this one we have a little bit of problem, you know why? Okay, when we're doing concept, today we're only teaching the meaning of the operations, okay? So we don't want to look at any algorithm. We only want to know what is addition, okay? So we want to know what is addition. Okay, this one, you actually can use this to show what is addition, but the only problem is in this activity, there's so many manipulators being used together, okay? Unifix cubes, you can use them separately on their own. Just Unifix cube alone can show a set model very nicely. You just take 3 Unifix cubes, 2 Unifix cubes of different colors, and then join it all together and show it's 5. Okay, so that's enough. I see you're using a 10 frame inside a place value board. All right, so I think this is not the proper way of doing it. You can use the 10 frame, but you must use it separately. 10 frames can be used to show the addition model, but you must use it separately outside of the place value board. If you use the place value board, then use the place value blocks, okay? Base 10 blocks. Use that only with the place value board. 10 frames, use separately. You can use the Unifix cubes with the 10 frames, but outside of the board, okay? Okay. It's okay lah, just little bit of mistake there when you use the place 10 value, okay? So before this was, what was before this? Okay, this one. When you explain the meaning of addition, okay, they have explained to you the meaning of the next screen. They explained to you the meaning of addends and sum, okay? You have to know what is addend. Each number that you add is called an addend, okay? Very good. Okay, but you don't have to talk about regrouping and grouping and regrouping and algorithms, all no need. Here we only want to know the meaning, because when we talk about operations, first we look at the meanings of the operation, what addition means, what subtraction means, and then we look at basic facts of operations. Each operation, what are the basic facts the students must learn. After that only we go into algorithms. Okay, so we don't have to talk about algorithms at all. You see down here the picture of the number line, the earlier screen. This is the measurement model. So concepts of addition, there are two concepts. One is the altogether model or set model, as you have seen in all the activities. And the second one is the measurement model. Measurement model, usually we use a number line. So we can see here from this diagram that, okay, it is a bit difficult to see the measurement model in the diagram. Maybe we have two jumps, okay? Maybe we have 10, or you can, because they are starting from 10, okay? So it is like 10 plus 3, okay? 10 plus 3 is 13, okay? So you must show one arrow from 0 to 10, second arrow from 10 to 13. So it's 10 to 10 plus 3. And you must show another arrow from 0 to 13. So we know that 10 plus 3 is equals to 13. So there are two models. One is the altogether model, which they have shown throughout the slides. And the second model is the measurement model, which is usually shown using number lines. Okay, that is the meaning of addition. Enough. No need to talk about algorithms. Okay, so okay, this group finished. Any questions, anyone? Okay, if you don't have questions, we go on to the next group.
Good morning, madam and everyone. Now our group is going to present the meaning of subtraction. Later, each of us will show one activity to introduce the meaning of subtraction. And first, I would like to introduce the concept of separation or takeaway in subtraction. And now I will share a video that I have taken earlier. The meaning of subtraction, I will prepare a place value chart with place value and sorry, can everyone see the video? Can you see the video?
Yes.
Yes.
Thank you.
Yes.
To teach the meaning of subtraction, I will prepare a place value chart with place value hundreds, tens, and ones, and use wooden stick as the concrete material. And there are 100 wooden stick in this bunch, and here are 10 wooden stick, and this is one wooden stick. Okay. And this means time 1, time 10, and time 100. Okay, now I will show the example. I will take this question as example 1. For question 1, 59 minus 13. So I will tell the student this 5 here means 50. So they have to take 5 bunch of wooden stick and place here. 1, 2, 3, 4, 5. And 9 here means 9. So they have to put 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And minus 13 means take away 13 wooden stick. So what I will tell the student, the 1 here means 10. So they have to take away 1 bunch of the stick here. Okay, and 3 wooden stick here. So now they can count, and it is the answer. 10, 20, 30, 40, 41, 42, 43, 44, 45, 46. And they know the answer is 46. Okay, and now we proceed to the second question. The second question is 81 minus 75. Okay, and I will tell them the 8 here means 80. So they have to put 1, 2, 3, 4, 5, 6, 7, 8. And the 1 here means 1 wooden stick. So 1. Okay, and now we need to minus 75 from 81. So means we need to take away 75 stick. As in the ones, there is not enough wooden stick already. So I will tell them to move one bunch of 10 stick to the place value 1. So there is enough wooden stick now. Okay, so take away 5. 1, 2, 3, 4, 5. Okay, and this 7 means 70. So we need to take away 70, means 7 bunch of stick. 1, 2, 3, 4, 5, 6, 7. Okay, so now we can count how many stick left, and it is the answer. 1, 2, 3, 4, 5, 6. So the answer is 6.
That's all is my presentation. Thank you.
Okay, let me just comment immediately about that presentation first. Firstly, it was very well done. You took the effort to explain that very clearly, but that is not what we want today, because today we are looking at the concept of subtraction. What you taught us was the concept of the meaning of subtraction operation. You've gone into the meaning of the algorithm, so it's okay, because they will still need to learn this later. So only one thing I want to mention is that when you actually perform the subtraction, you must start from the left to the right. Okay, in your first example, I saw that you took out the tens first and then only you took out the ones. So that's wrong. Okay, you must start always from the ones and then go on to the 10, like how you did in the second example. Okay, both the examples shown very well, but actually it's not for today's one. You're actually explaining the meaning of the operation. We want the meaning of the concept of subtraction. You understand, Yan Hui?
Okay, thank you, madam.
Okay, but you did the video very well. Okay, let's continue.
Can everyone see my screen?
Yes.
Yes.
All right, thank you. So now I'm going to show the meaning of subtraction as separation or take away using star as counter. I should use concrete like marbles or stones to demonstrate this, but since we meet online, so I just use picture on screen. Okay, let's say we have 5 stars here and we take away 2 stars. And there are 3 stars left. So this process of taking away a quantity from another quantity is defined in mathematics as subtraction. It can be written as 5 minus 2 equals 3 in symbol, and in sentence we say subtract 2 from 5 equals 3. Subtract 2 from 5 equals 3. Next, I will explain the meaning of subtraction as comparison. Okay, let's say there are two sets of stars, one with 5 stars and one with 2 stars. The first set, here got 5 stars, 1, 2. So the first set has 3 more stars than the second set. This process of comparison of two sets also can be written as 5 minus 2 equals 3 in symbol, and in sentence we say the difference between 5 and 2 is 3. That's all from me. Thank you.
Can you give us, Yunjun, can you give us one word problem in which the student will do it like this, subtraction as comparison?
What problem?
A word problem, a story. In which kind of story will the students do it like this comparison method?
Is the word problem can be in a question form?
Yes, a story, just a problem solving.
Oh yeah, okay. So the word problem can be example like Siti have 5 stars and Ali have 2 stars. So Siti have 3 more stars than Ali.
If it's in the form of question, Siti
no.
has 5 stars.
And Ali have 2 stars. So Siti has 3
How
more
many?
stars.
How many more stars does Siti have? Okay, so when you have that kind of a question, Siti has 5 stars, Ali has 2 stars. How many more stars does Siti have? When you hear that question, straight away you think of subtraction as comparison. You know they're talking about how many more. So you're going to compare the 5 and the 3, and then 2, and then you see there's 3 more stars. So it's 5 minus 2 is equals to 3. So 3 more stars. So this is a comparison problem. Go back to your earliest slide, please. Takeaway. Okay, so Yunjun has given us 2 concepts of subtraction. The first concept is concept of subtraction as takeaway or separation model. Okay. Second one is subtraction as comparison. We don't have to tell the student all these names, but we must model it. We must give them like word problems where they can solve it using these models. Okay. So here in this takeaway model, whenever you use takeaway, if you show the diagram like this, for me, it looks like 3 plus 2 is equals to 5. Okay, so how do we show a takeaway model? So I look at the 3 stars and I look at the 2 stars and I think 3 plus 2 is 5. Okay, I want to take away. So I don't have to show the 2 stars. Okay, I only show the 3 stars. And to show a takeaway model, either you move the 2 stars away, so remainder only 1. So that means you must start off with how many stars? You must start with 5 stars. 5 stars, move the 2 away or cancel it away. You must show that taken away, thrown away. Okay, so you cancel the 2 stars, so you left 3. So students can see that they start with 5, you cancel 2, remainder 3, take away. Or if you, this is a static model, or if you want to show a active model, you can show like a tree with 5 birds, and then 2 flew away. You can show 2 flying away and 3 more still on the tree. And then your question sentence will be 5 minus 2 equals to 3. Okay, so for addition and subtraction, the way we represent the sentence is a little bit different. For addition, you show both the addends. Okay, you represent both the addends with counters or models or whatever. Okay, but for subtraction, you only show the bigger number. You only represent the bigger number, whether you're using base 10 blocks or anything. You only show the first number, the bigger number, and then you take away from there, throw away from there. okay? We never represent the two numbers on using subtraction, okay? Okay, so good, very clear both concepts, okay?
Okay,
Next.
thank you, madam.
Okay. Hello everyone. Can you see? Okay. For the meaning of subtract, I'm going to tell you guys about using number lines. You guys can use whiteboard, mini whiteboard, or like this. I'm using Ziploc, so I can erase it using tissue, and student also can do it. Okay. For example, firstly we draw number line 0 to 10, and then we give question here. For example, 9 to 4. How to use this number line? Firstly, we start with first number, which is 9. So we starting here 9, and then to the left, take 4, 1, 2, 3, 4. So the answer is 5. So student will know the difference between 9 minus 4 is 5. Okay, another example. Maybe 10 minus 3. Okay, so we start first with first number starting from 10, and then count to the left, take 3 place, 1, 2, 3. So the answer is 7. Okay, that's all from me. Thank you.
Okay, Aisha, good. You showed how to use the number line to demonstrate the concept of subtraction. Okay, good. Next.
Okay, I will continue. You can see my camera. Okay, this is feed a hungry penguin. Okay, this hungry penguin, student can learn how to subtract, and this is the story for this. Okay, this for example is have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 fish. So based on the sentence, so there were we already on it 10 fish in the water. The penguin is, for example, 6. 1, 2, 3, 4, 5, and 6. So you can see it. The penguin ate 6 fish. There are 1, 2, 3, 4 fish left. So we write it. There were 10 fish in the water. Penguin ate 6 fish. There are 4 fish left, and this is for the equation. So we take 10, subtract to 6, and the answer is 4. So this we can see the two number of the equation make the answer more smaller. Like that. So the student will see the subtraction make it the answer more smaller than equation. Something like that. Okay, thank you. Sorry if I am mistaken.
So actually, what was that? What concept was that for?
But to number of subtraction, and the answer will become more smaller than the question.
Okay. But I couldn't see very clearly all together, but it's okay lah. Okay. All right. Next person. Anyone else in the group?
Daniel. Sorry. Okay, I will wait and do activity like count the rubber band. So here is five rubber band, which is 3 yellow color and 2 red color. So the question is 5. What was the question? 5 minus 2. So there is 5 minus 2, which is 2 red rubber band. So we can see the answer is 3 yellow rubber band. So what I want to say here is the multiple operation is how many things left after we take away from that. That's all for me. Thank you.
Okay, wait, just hold on with the diagram. Let me see that for a while, okay? Okay, firstly, when you want to show 5 minus 3, we cannot show like this. This is not the same as addition. So for subtraction, we only can show the first number, okay? Let's just look at the first picture. There are 3 yellow rubber bands and 2 red rubber bands. If I say, you see there are 2 colors there, okay? So actually this is showing a different model of subtraction, a different concept of subtraction. If I say there are 3 yellow rubber bands and 2 red rubber bands in a basket, say on a plate. If there are 3 yellow rubber bands, how many red rubber bands? So what model is this? Is this comparison model?
Yeah.
It is not comparison model. We are not asking how many more, how many less, okay? It is not takeaway model. We are not taking away. But so this is a part whole model, okay? This is a concept of subtraction part whole. The whole is 5 rubber bands, okay? One part is 3 yellow rubber bands. So we are asking what is the other part, okay? So if there are 5 yellow and red rubber bands and there are 3 yellow rubber bands, how many red rubber bands there are? So the answer is 5 minus 3 equals 2. Okay, so the first diagram alone shows the part whole model of subtraction. Okay, so for subtraction, don't show the whole thing, only show the first one and then show either it's moving away or you're cancelling it or something. Okay, okay, done. Thank you.
Sorry, madam. Thank you.
Any more?
No more. 5 only.
5 only, yeah? Okay. Okay, so thank you to this group. Okay, so I didn't see one model. Okay, I didn't see the missing add-on model. Anybody knows what is that? Okay, so we just now we looked at subtraction. Okay, so I think that we saw the take away model. Okay, this is very important. Take away model. Second model was the comparison model. Comparison model. Third model was what was the third model? The third model is actually the missing add-on. You know what's an add-on, right? Just now you saw what's an add-on. And actually there's one more model which is the part whole model. Part whole model which we saw just now. This one was the part whole model, was the rubber bands just now. Okay, if you had 3 yellow rubber bands and 2 red rubber bands, okay, if you know there's 3 and you know that altogether there's 5, how many red rubber bands? Okay, so this is part whole. The whole is 5. You know that one part is 3, so the other part is 2. Okay, this is the part whole model. Missing add-on model. Missing add-on model is, I give you one example. Missing add-on model. Say a garage can hold 5 cars. Okay, there are 3 cars in the garage. How many more cars can enter the garage? Okay, the garage can hold 5 cars, so you know that all together is 5. A garage can hold 5 cars, all together is 5. There are already 3 cars in the garage. Okay, so how many more can enter the garage? This is called a missing add-on. This is a missing add-on. Add-on is usually used for addition. So 3 plus what gives you 5? So the add-on here is missing. To answer this question, you have to change it to subtraction. 5 minus 3 equals to what? So 5 minus 3 is equals to 2. Okay, so this is how a missing add-on problem looks like. Okay, so you already know the whole total and you know one part and you want to find what's the other part. So you write it like a missing add-on and then you do the subtraction. Okay, so this is a missing add-on concept. So subtraction has 4 concepts. Takeaway, comparison, missing add-on, and part whole. Okay, okay, class?
Okay, madam.
Okay, I
Very
want to read
clear.
the question. Okay, you tell me
Yeah,
what
madam.
kind of a model is this. Okay, I'm going to read the question. You tell me what subtraction model is this. Sophie has 12 balloons. Then 3 of them floated away. How many balloons did she have left? What model is this?
Takeaway.
Takeaway.
Okay, very good. Very good. Okay, next. Emily caught 4 fish. Cameron caught 11 fish. How many more fish did Cameron catch than Emily?
Comparison.
Comparison.
Yes, very good. Comparison model. Okay, one more. Ashley's team needs 14 points to win their game. They have scored 9 points. How many more points do they need to score?
Missing add-on.
Okay, very good. So if you can identify the concepts of subtractions from the word problems, that's very good. Okay, so that means you understand what is the 4 models of subtraction. So we have seen addition and subtraction. Okay, addition, we have seen 2 main models, that is the altogether set model and the measurement model, number line model. Subtraction, we have seen 4 different models. Takeaway, comparison, missing add-on, and part whole model. Okay, so far so good. Okay, next we go on to multiplication. So Nadia's group.
Yes, madam. Semua nampak tak?
Nampak.
Nampak nak?
Okay, good afternoon, everybody. So, my group members and I are going to present the meaning of multiplication through concrete manipulative and activities. Okay, before that, I'll tell you the meaning of multiplication first. Okay, what is multiplication? Multiplication is the learning of multiplication facts involves a progression of higher order thinking skills in order for a student to reach fluency. Fluency of these facts is described as happening in 3 successive phases. So, phase 1 involves modeling or counting to determine the answer. Phase 2 involves deriving the answer using reasoning strategies and critical thinking. And phase 3 is automatic retrieval or mastery of the facts. Okay. So there are 4 key areas to understand the progression through multiplication. First, students' conceptual understanding. Second, barriers to conceptual understanding. Third, recommendations for teaching basic multiplication. And fourth, strategies for teaching multiplication concepts. So the next slide, students' conceptual understanding will be presented by Nadia.
Okay. For the student conceptual understanding, we have 3 points.
Nadia, is there a slide that you're showing? Are you showing some slides or something? Because I cannot see anything.
Cannot see, madam.
Cannot. How about the others?
I can see, madam.
Can see it.
I think
You can
madam
see?
need to unpin someone.
Can you see now, madam?
No.
Okay. Wait. What about now?
I cannot see. But are you presenting something? Are you showing a slide or something?
I'm presenting slide.
How about the others? Can you see?
Yes, madam.
Yes.
I can see.
Oh, I alone cannot see. Okay lah, now you present. I don't know what happened.
Okay, next is student conceptual understanding. We have 3 points, which is first, reasoning versus memorization. In multiplication, mostly when we in primary school, we use memorization for multiplication, which is we memorize the CFA. And second is developing number sense, which is students' ability to think mathematically and derive answer rather than depending on rote of memorization. And last is eventually fluency of facts. One of the key foundational learning challenge in elementary mathematics is developing fluency of the basic 0 until 12 multiplication facts. Next is barriers I think Aida will present this.
Okay. Next case is barriers to conceptual understanding. First is about number sense. Second is about prior knowledge. Third, misunderstanding the properties. So, in order to understand the multiplication concept, we must already have the knowledge about the multiplication um, in order to gain the conceptual of multiplication. So, um, so we can avoid other misunderstanding or understanding multiplication conceptual. Okay, next I will pass to Huda.
Okay, I will continue with strategies for teaching multiplication concept. First, we can see that the strategies is repeated addition. So, repeated addition is a method for solving multiplication problems where one multiplicate is added for as many times as the other multiplication. So, student must understand the relationship between repeated addition and multiplication. So, as we can see, the example, 3 multiplied 6 is equal 3 plus 3 plus 3 plus 3 plus 3 and plus 3. So, 3 added 3 by 6 times and added 6 by 3 times and equal to 18. And second strategies is making equal groups. And from these strategies, students can draw picture or groups of tally marks to represent the multiplication problems. So as we can see that, for example, 7 multiplied by 3 could be drawn as 7 equal sets of 3 tally marks. So the student will draw this representation and then count each circle to determine the product. So this visual method is for 7 multiplication can be time consuming as each student must count the number of group, draw picture, count the objects in each group and then count the total. So for the example, from this example, student can count each the tally marks. So 7 multiplied 3 is equal to 21 tally marks. The third strategy is number line. For example, 3 multiplied by 5 would be represented by starting at 0 and jumping over 5 numbers at a time for 3 jumps or iteration. So teacher can use this number line to show how repeated addition is actually skip counting on the number. As you can see the picture, 0 to 5, 5, 10 and 10 to 15. So it actually skip 5 number at 3 times. Or we can do the same times for 3 for added by 3 for 5 times. And next is array strategies ataupun susunan strategi. For example, 3 multiplied by 4, that means we need to book 3 multiplied by 4 arrays so that it is
Sorry. Can you see the slide?
Yes, ma'am.
Yes.
Okay, I will continue. So the five strategies we can use in the multiplication concept is decomposing numbers. So decomposing numbers is a multiplication strategy that allows students to break apart more difficult problems into smaller, less challenging problems that are easy to solve. So for example, that you can see is 7 multiplied by 3, and we can decompose 7 to 5 and 2. And we can see that partial product is actually 8 times 3 equal to 15, and 2 times 3 is 6. So the partial product we need to add, and we can get the answer. So 7 times 3 is 21. So
For teaching basic multiplication. Okay, we continue that. Thank you. Next, recommendation for teaching basic multiplication. So we can use also congruent ability. Next. Next. Okay. What is congruent ability? Relative concrete, physical or visual tools which allow teachers and students to represent abstract, able to scale, understanding and simplify. So concept is about, so we can as a visual to create a visual manipulative. Okay, for example, now we could.
Okay, example of concrete manipulative. First, Western blocks representations of physical object used for constructing mathematical understanding. For example, 4 by 6 equal to 24. So we are connecting 6 blocks in a row to form one group. And we will have 4 rows to have 4 groups. Then 4 equal to 6 equal to 24. Or we also can connecting only 4 blocks in a row to form one group and use 6 rows to form 6 groups.
What model is this? Aida, is it? What model is this? 4 times 6 is 24. What concept of multiplication is this?
Commutative.
Commutative, but you haven't shown that. I mean, if we don't look at the commutative, just this picture alone, what concept is this? Anyone? This picture that you're showing here, the first we see 6 and then another 6, another 6. 4 times 6 is 24. What concept is that? You're not sure? Okay, then go on.
Yes.
Go on.
Okay,
so
that's
how
all from us.
Can you just run through all the slides from the beginning, please? Because I couldn't see the first few slides. Start from the first slide, just go. Okay, 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 okay. Okay, okay, okay. Okay, go back to number 1, repeated addition. So repeated addition, making equal groups. Okay. Okay, next slide. Okay. Okay, okay, enough. Okay, so just to ask everybody again, so how many concepts of multiplication do we have? How many did you see here? Okay, you can stop presenting. Okay, so for multiplication, okay, so let's look at the first concept. I didn't see this concept very clearly, but this is the set model, okay? Set model, when you say 3 times 4, what you mean by 3 times 4 is 3 sets or 3 groups, okay? So you have 3 groups, 1, 2, 3. Each group has 4 objects in it. Okay, each group has 4 objects. So 3 times 4 is equals to 12. This is the set model, okay? Or we can also call this as the repeated addition model, okay? Repeated addition model, okay? So we are adding 4 3 times. This is 4 plus 4 plus 4. Okay, so also equals to 12. Okay, repeated addition model or the set model, okay? The second model is, okay, second model is the, let me see, yeah. It's the comparison model, okay? Comparison, or it's also known as the measurement model. Okay, this model is like this. If say if city has a ribbon that is 2 centimeters long ribbon, okay? If city has a ribbon that is 2 centimeters long, and say and Nora has a ribbon that is 3 times longer than cities, okay? Then how long is Nora's ribbon? So cities one is 3. Nora has a ribbon that is 3 times longer than city. So 3 times 3 is 9. Okay. So this is the comparison or the measurement model. Okay. And then the third model is the array model. Okay. This is a very important array or area model. Okay. We have 2 models here, array area or array model. Array is turus in Malay. Array means row and column, okay? When you say 3 times 4, it means 3 rows and 4 columns, okay? So you have 3 rows here, 1, 2, 3, 3 rows. Each row has 4 columns, 1, 2, 3, 4. This is 3 times 4. If you drew it this way, 3 columns like this, and 4 rows, this will be 4 times 3. Okay, so that's the difference between 3 times 4 and 4 times 3. Okay, the number in the front is always the number of rows. Okay, same with the set model. Okay, this is 3 times 4, or if you had 4 times 3, 4 times 3, it will be 4 times. So you have 4 groups. Okay, 4 groups. Each group has 3. Okay, so 3 times 4 and 4 times 3, the meaning is different. Okay, so you must understand that when you teach the model. Okay, so this is the array model. Area model is something like an array model, but area we straight away go into the area. 3 times 4. Okay, 3 times 4. One dimension is 3, the other dimension is 4. Because for multiplication, 3 times 4 is always the area. Okay, length times width. Okay, and one of the numbers can be length, one of the numbers can be width. So multiplication, we always connect to area. Okay, 3 times 4. 5 times 2 will actually mean a rectangle where the length is 5 and the width is 2. Or length is 5, width is 2. Area is 10. Here area is 10. Okay, so 5 times 2 is equals to 10. So multiplication, we always relate to area, and the other method is area model. Okay, and the last concept of multiplication is the combination model. Okay, combination model. Combination means say you have three different types of cakes, three different types, and you have two different types of drinks. Okay, say you have a Milo and you have tea here. Okay, and cakes, say you have, I put them in quail. Okay, say you have cake 1, cake 2, cake 3 and 4. Okay, 3, cake 4. So if each person can only take one type of cake and one drink, how many different combinations are there? Okay, so we have cake 1, you can take cake 1 and you can take Milo or tea, or you can take cake 1 and you can take either Milo or tea, or you can take cake 3 and take either Milo or tea, or you can take cake 4 and take either Milo or tea. So how many different combinations are there? There are 8 different combinations. So 4 times 2 is 8. Okay, so this is the combination model. Okay, so for multiplication, just like subtraction, there are 4 different models to explain the concept of multiplication. Okay, the set model, the comparison or the measurement model, the area or the array model, and finally the combination model. Okay, some of these models were explained well by the group that presented just now. One or two I didn't see. Okay, so that's all for multiplication. Thank you to the group. Okay, so we go on to the last and final group for division.
Okay. Okay. My group will present division. So next slide is. Okay. What is division? The division is a primary arithmetic in which numbers are combined and divided in such a way that it forms a new numbers. This means that we will divide one number with another and a whole number, third number will be formed. Division is a method of grouping objects equally in groups, such as arranging students in row during assembly. Okay. Okay, it's two way of division. Is what is partitive division? A partitive division problem is a one where you know that the total number of group and are trying to find the number of items in each groups. For example, there are 24 flowers equally distributed in 8 vases. How many flowers are there in each vase? Let us see how we can find the answer to this question. Here we have 8 groups and we have 24 flowers. Start by placing one flower in each group. On placing one flower in each group, we place 8 flowers in each group. So we are left with 24 minus 8 equal to 16 flowers. Okay. Place one flower in each group. Now we have placed another 8 flowers in the 8 group. We are left with 16 minus 8 equal 8 flowers. Again, place one flower in each group. After place the last 8 flowers in 8 group, we are left 8 minus 8. So 0 flowers. We see that there are 3 flowers in each group. Okay, I will pass to Maisara.
Okay. Next division is to find the number of items group. We can directly divide the total number of items divided by the total number of groups divisor. The question obtained is the number of items in each group. As you can see in the box, the number of items in each group is known as question, and number of group is known as divisor, and the total number of items is dividend, and the number of items left is remainder.
Okay, next continue. This is one of the method of division. So this is a measurement division. So measurement division is a way of understanding division in which we divide an amount into a group of a given size. And then, for example, we have 12, and then we want to divide it into 3 groups. So it means that 12 things, the total of the things we have is 12, and then we divide it by 3. So we will have the answer for 4. So we have 4 groups. In the 4 groups, we have 3. Okay. After this, I will share about the example. So I proceed to Khairul.
Okay, there is a lot of methods or concept in division. So one of them is repeated subtraction. So repeated subtraction is a method that subtracts the equal number of items from a group, also known as division. Using this method, the same number is subtracted repeatedly from another larger number until the remainder is 0 or smaller than the number being subtracted. As you can see the example below, 8 divided by 2 is equal to 4. Why it is equal to 4? We can see 8, we repeatedly subtract it with 2. Then we can see there's a 4 for subtraction of 2 until it the 8 will become 0. So 8 divided by 2 is equal to 4. Next is number lines. A number line can be used to divide. To work out 12 divided by 4 counts how many jumps of 4 it takes to get from 0 to 12. 3 jumps or groups of 4 means 12 divided by 4 is equal to 3. As you can see, there's a number line which is 0 to 12, as you can see. So we start at 12 because 12 divided by 4. So we jump or group it to four numbers backward. So we can see that it can form 3 groups until it reach 0. So there is a 3 group, means that 12 divided by 4 is equal to 3. Next, I continue with Haziq.
Okay, so this is the for my example. So division using counters. This is one example. So it involves collecting the numbers being divided into equal groups and counting how many groups can be made. The amount in each group is the number being divided by, and the number of group that can be made is the answer to the division. Okay, so this is for 12. There are 12 counters there, red circle. Okay, so we have 12. So we want to divide it by 4. So we can take 4 counters in each. So it will form a 3 group there, as we can see in the diagram. Okay, next. Okay, this one also another example. So we use 10 counters here. So we want to divide it by 2. So we take 2 in a total of 10, take 2, and then take 2, and then take 2, until we have a group. So we can see below there we have 5 groups of 2s. So this is one of the how we can picture how division works. So 10 divided by 2, and then we get 5 groups. Okay, next. Okay, array models. So array models also the same. In array model, in the array division model, you divide to find the numbers of counters in each group. So the same 3 numbers are used, and then the model shows that division undoes multiplication and multiplication undoes division. So when multiplying or dividing, students can use the fact from the inverse operation. So when we use the array models, we can see that it also uses multiplication. So if we can see the first diagram in the left side, we can see that 3 times by 6 equals to 18. So we can see column, the column has 3, and then the first row is 6. We can just multiply and we got 18 for the total. So we can undoes this multiplication. So it's like inverse operation. We can use the total of the whole array models. Then we will divide it by 3. Divide it by 3 groups. So we can take from the first row, the second row, and the third row. Okay, for the total of 18, the first row there are 6. So we group it by 1. Okay. The second row, there are 6. This is the second group, and then the third one is the third group. There are 6 also. So we can see that the grouping there are 3. It's divisor by the divisor is 3. So we divide it by group. So 18, we take it. There are 1, there are 2, and there are 3. Then we have 6. 6 objects in one group. So there are that's how it works. Okay, next.
This is the end.
Okay, that's all from our group. Thank you. Sorry for my stutter.
Okay, I think this group presented very well. I think it's very clear. Okay, just want to ask how many What are the two main division concepts here? Anyone? What are the two main division concepts that we saw? Daniel?
Set.
What are the two main division set? The first model is the
Repeated subtraction.
Yes.
repeated subtraction. Repeated subtraction is connected to which model?
Set.
Partitive.
Repeated subtraction, partitive, because when you explain the repeated subtraction, it was very clear using the number line and the you took away 2, 2, 2. So when you take away 2, 2, 2, is that partitive or is that measurement or grouping model?
I'm not sure, madam.
Sorry, madam. It's measurement.
Okay. Yeah, why is it measurement?
Because we subtract, we not group it.
Yes, okay. Okay, it's correct, it's measurement model. So we saw just now that you actually showed us two different models. One is a measurement model, division as measurement model, or division as grouping. We call this division as grouping. Or the other two, second one is partition or partitive model, okay? Partition or partitive model, or we say division as sharing, equal sharing. Okay, so these are the two main models, measurement and partition, or you can call it as grouping or equal sharing. This is easier to remember, grouping and equal sharing. Supposing you had, say you had 12 sweets, okay? You had 12 sweets and you want to give 3 sweets to each child, okay? So you have 12 sweets and you want to give 3 sweets to each child. So this 3 goes to child number 1. This 3 goes to child number 2. This 3 goes to child number 3. And this 3 goes to child number 4. So how many children get sweets? 4. So what is the sentence that you want to write here? You know altogether there are 12 sweets. You want to give each child 3 sweets. So it's 12 divided by 3 equals to 4. So if you have a problem like that, you will write the sentence like this, okay? You will write the sentence 12 divided by 3 is equals to 4, okay? If you had 1, 2, 3, 4, 5, 6. Okay, 12 sweets, and you want to divide the sweets among, say you want to divide the sweets among 3 children or 3 children, say you want to divide the, or if I say I have 12 sweets, I have 12 sweets and I want to give to 4 children, give to 4 children equally, okay? How many sweets does each child get? How many sweets does each child get? So I want to give to 4 children, right? 1, 2, 3, 4. Okay. I give 1 to this child, 1 to this child, 1 to this child, 1 to that child. Okay. Then I do again because I want to divide equally. 1, each one gets 1, 1. Okay. Then I do again. 1, 1, 1, 1. So now how many does each child get? 3, 3, 3, 3. So what is the division sentence or the mathematical sentence? I have 12 sweets. I divide it into, I only know this, okay? 12 and 4 only. So I divide into 4. I get 3. Okay? So that is the two different concepts of division. We don't have to tell the child, this is measurement model or this is partition model, no need. But when you give them the word problem, this is how you must explain, okay, what is 12 divided by 3? You give them a word problem and then from the word problem, they write the number sentence. Sometimes the number sentence will be like this. Sometimes it will be like this. Okay. So the number sentence can mean different things. Okay. That is what we need to understand. And when we say repeated subtraction, okay. So 12, which one looks like repeated subtraction to you? The first one or the second one?
The first one.
Yeah, the first one, right? So here we will take away 3, 12, take away 3, take away 3, take away 3, take away 3 until you're left with 0. So you have 1, 2, 3, 4 groups of 3. Okay, so repeated addition is related to division as measurement model or grouping model. Why we say measurement model? We measure 3 and we give it to one child. We measure 3 and we give it to one child. We measure 3 and give the other child. Okay, that's why it's known as the measurement model. The other model is partition or equal sharing, because we give 1, 1, 1, then we continue giving until everything finishes. Okay, that is equal sharing. Okay, so these are the two concepts of division. Okay. Okay, I'm going to read one story to you. You tell me what concept is this. Anthony buys 54 oranges. If he puts an equal number of oranges in 6 bags, how many oranges will be in each bag? Is this measurement model or partition model? Anthony buys 54 oranges. If he puts an equal number of oranges in 6 bags, how many oranges will be in each bag?
Partition.
Partition, yes, partition. So he put 1 in each bag until he finishes. Okay, partition model. Okay, what about this? There. Wait, I'll give you another one. Jessica bought 32 oranges. On another one, wait. Matthew was given 48 trading cards. The cards were in packs of 6. How many packs did he receive? Matthew was given 48 cards. The cards were in packs of 6. How many packs did he receive?
Measurements. Repeated subtraction.
Model, because already measured into packs of 6. Okay, so how many packs did he receive? It's measurement model. Okay, so whenever we use word problems, actually is a good way to start to teach anything is using word problems. Okay, problem-based teaching. So when we use word problems to show them the concept of division, okay, because different problems can have different concepts of division. Although they all look like division, you write it in the same way, but they actually mean differently. Okay, that's why the teacher must understand all these different concepts of division. Okay. So thank you to all the groups that presented just now. Okay. Okay. So this one, we are going back to this one for a while. Just run through very quickly. The first sentence is an addition sentence. Okay. So you already saw, they already explained to you that this is known as the, what do you call this? Each number here is known as the
Addends.
Yes, addends. You must remember this. ADDEND, addends, and this one is known as the sum. Okay. Addition is also known as the part whole model. Okay. This is one part. This is one part. Together they become the whole. Part whole model, or each number here is known as the addend. Okay. For subtraction, you need to know all these names. This is called the minuend. Okay. This is the subtrahend. And finally, we have the difference. Okay. In subtraction, we start with the whole. Whole, take away one part, you have another part. Okay. That's why subtraction always starts with the biggest number. So when you do subtraction concretely, you only have to show the whole number first. From there, you take away. Okay. So subtraction is whole, part, minuend, subtrahend, and difference. Okay. for multiplication, this first number here is known as the multiplier. Second number is known as the multiplicand. And the answer is known as the product. Multiplier, multiplicand, and product. Or these two numbers can also be known as the factor. We call these 2 and 3 are factors. Okay, what this multiplier means? In multiplication, you must know the first number here actually means the number of groups, or the number of sets, or the number of jumps, or the number of rows. Okay, this is number of. Okay, the multiplicand represents the number in each group. Okay, the number in each group or set or row, or the size or the length of the jump. Okay, in multiplication, this is what the first number means, and this is what the second number means. Okay, and then we go on to division. Division, as you've seen just now, this is dividend. Second number here is the divisor, and this, your answer is the quotient. Okay, division, like subtraction, this is the total. We start with the total, and we have one part is given, and we find the other part. Okay, we can see from here that division and multiplication is related to each other. Okay, and subtraction and addition are related to each other. When you use a number line to teach, okay, for addition and for multiplication, we move forward. Okay, for division and for subtraction, we move backward towards the left. Okay, this is how we teach that. Okay, okay, one more thing that I want to show you is fact families. Okay, fact families. When we learn, we always learn in fact families. Okay, 4 plus 5 is equals to 9. This also means that 5 plus 4 is equals to 9. You already know this principle. What is this principle called?
Commutative.
Yeah. Commutativity or commutative principle only works for addition and multiplication. It doesn't work for subtraction and division. Okay, so 4 plus 5 is equals to 9. 5 plus 4 is equals to 9. 9 minus 4 is equals to 5. 9 minus 5 is equals to 4. Okay, so therefore this is called as a fact family, one fact family for 4 plus 9. Similarly, for 6 times 7, we can write out the fact families here will be 7 times 6 is 42. 42 divided by 7 is equals to 6. 42 divided by 6 is equals to 7. This is called a fact family. Each fact family has 4 facts. Okay, addition and subtraction make one family. Multiplication and division make one family. What we mean by fact families is that if the student knows one fact like this, if the student knows that 4 plus 5 is 9, from here the student can work out that 5 plus 4 is also equals to 9. And if you don't know, say you don't know this one, from here the student can work out that 9 minus 4 is 5, because the student knows that 4 plus 5 is 9. And from there you also can work out that 9 minus 5 is 4. Similarly, if they know this fact, 6 times 7 is 42, they don't have to memorize 7 times 6. Because you know 6 times 7 is 42, straight away you know that 7 times 6 also 42. And from here you can also see that 42 divided by 7 will give you 6, and 42 divided by 6 will be 7. So